Good morning, Topology gang. Hope you guys are doing well. As you can see in the top of my iPad screen, hopefully you can see the little text. It's Wednesday. I wanted to dive into the next section with you, and let's dive in. We're going to be talking about metric spaces today. Really fun, and this will kind of help connect topology with a lot of your intuition. So let's begin. So I want to start with a non-empty set X, and if you think about it, that's what we've really been working with. All of the topology that we've done so far, we've been working over a non-empty set, and then we've looked at a collection of subsets of that set and formed a topology. So I want to go back to just a non-empty set X, and I want to tell you what a metric is today. And so a metric is a real valued function. What does that mean? Well, it's a function that maps takes an ordered pair from your set and maps it to the non-negative real numbers. And so let's make this clear here. X cross X. What does that mean? What it looks like is this. Let me show you. It looks like maybe you have off to the side here. Let's do it. Maybe your set X is the set A, B, C. So you can plug in pairs from the set. You could, for example, talk about D of AB, or you could talk about D of CB, or so on and so forth. And whenever you plug in a pair of elements of your set X, you're going to get out a real number, and that real number is going to be non-negative. It can be zero. Zero is included, but it's not going to be negative. So maybe D of AB would be 2 and D of CB might be 107 or who knows what, right? So I'm going to erase that now, but that's the idea. We've got a set. We can plug 2 points from my set into this function. The function is called a metric, and I get out a real number. But to be a metric, I do need to satisfy some properties. So here they are. The first one is that the D of xy is 0 if and only if x equals y. And by the way, I'm going to start referring to D as distance. So D really is a distance function. So I want the distance between 2 points to be 0 only when the points are the same. That makes sense. Second property is, boy, I really don't want the distance between x and y to be different than the distance between y and x. Those ought to be the same. So we insist on that. And the final property is known as the triangle inequality. It says that, hey, if you have the distance between 2 points, that should be less than or equal than the distance between x and some other point z plus the distance between z and some other point y. And take a moment and see how this fills in. So I'm looking at x and y, and I've still got those same points x and y on the end, but I am now looking at d and x, x and z, and then the distance between z and y. And this distance has to be less than or equal to these two. So this property is known as the triangle inequality. So that's the definition of a metric. And so I think I'll do an example with you in this video, and then we'll go on to the next part. So I thought we'd start with the standard metric on the real. This will be familiar to you. So we're going to, let's define our metric D like this. D of x, y, I'm going to define as the absolute value of x minus y. And now I just have to show that these three properties are satisfied by my metric D. Well, I'm not even going to write anything for 1 and 2 because it's clear that the distance between x and y is 0 precisely when x equals y. So 1 is clear, right? The absolute value of x minus y is 0 if and only if x equals y. 2 is also clear. It doesn't matter. You can pop the negative sign out. So let's just say, I'll just say 1 and 2 are clear. We should be careful using that word clear. That's a dangerous word to use. And then what about the third property? Well, it's the most interesting. Let's go ahead and point out that we know, actually I need to zoom in here, sorry. There we go. So we know that in general, A plus B is less than or equal to absolute value of absolute value of A plus absolute value of B for any real numbers A and B in R. And so we're going to use that fact. So if I want to look at the distance between x and y, that's just absolute value of x minus y. And now I'm going to slip a z in there. That's the same as x minus z plus z minus y. I'm going to group these together as x minus z plus z minus y. Same thing. And now I'm going to use the fact that I have the triangle inequality. If I just have one real number, A, plus one real number, B, then I can break it up. Well, that's a real number and that's a real number. So this is less than or equal to the absolute value of x minus z plus the absolute value of z minus y. Well, gosh, that's just the distance between x and z plus the distance between z and y. And so we've actually shown that 3 holds. And so we'll say thus D is a metric on the reals, and of course you should identify this as the standard metric. I say it's the standard metric because it's exactly the way that you've always measured the distance between two real numbers. Let's draw a number line and think about it. If you want to know the distance between A and B, we typically think of the distance as this length, and this length is exactly the absolute value of either b minus a or a minus b. It doesn't matter. So this is your typical notion of length. I have to warn you that there are a lot of other metrics, and there's a lot of other notions of distance that you're not used to. So not everything we do is going to be is going to follow your intuition. So let's stop this video here, and then we'll